Welcome to the inaugural launch of the Connect with TrueSight webinar series. This is a support-driven monthly webinar series covering topics from product usage to troubleshooting. All webinars are recorded and will be posted to communities and our YouTube channel. During the presentation, you are able to ask questions to our panelists, and all the Q&A will be posted alongside the presentation recording. Today's topic is running and understanding TSOM Health Check tool, and Jonathon Macey will take us through this content. Over to you, Jonathon.
Thanks, Greg, and hello, everyone. As mentioned, I'm Jonathon Macey, a lead technical support analyst, and I've been at BMC for over 20 years, always working within customer support. I've supported a variety of products over those years, from SQL Backtrack to Smart DBA Cockpit, Patrol Express and Performance Manager Portal, to ProactiveNet and TrueSight Operations Management. In this webinar, we will be looking at the TrueSight Operations Management, or TSOM for short, Health Check tool, what led to it being created and what it checks. We'll see the places you can get the health tool from, what's new in version 2.1, what is being considered to be added in future releases, and how to both run and interpret the output of the tool. First of all, though, we will look at what TrueSight Operations Management is, should you just call it TrueSight, and some of its architecture. TrueSight is actually a BMC brand name that covers an array of products such as server automation, capacity optimization, orchestration, smart reporting, and of course TrueSight Operations Management that our session is about today. TrueSight Operations Management combines some of the aforementioned products, and it enables IT departments to monitor the performance and availability of the infrastructure and applications that comprise their services. It monitors events coming from the infrastructure devices and transactions from the applications that enable the services they deliver. The area we are looking at today covers infrastructure and event monitoring, which is done by the TrueSight Infrastructure Management Server, also known as the TSIM. The TSIM helps you detect and address performance abnormalities before they impact the business. It automatically learns the behavior of your infrastructure, telling you what's normal and only issues alerts when behavior needs attention. This helps you focus on the events that matter most to IT in the business. The TSIM feeds into the TrueSight Presentation Server, or TSPS, which hosts the web-based TrueSight console functions and consumes data from various TrueSight products to provide a consolidated set of views for monitoring the infrastructure, real and synthetic applications, as well as capacity planning. Here is a TSOM Architecture slide. Now, we're not really discussing this, but it just highlights the complexity involved in monitoring your environment, and that's without giving detail to all the different main processes for the TSIM and TSPS. It is this complexity that can mean difficulties may arise in trying to determine exactly where the root of a particular problem might lie. With this in mind, let's look at some of the common issues in TSOM. Sometimes the TSIM or TSPS consoles may feel a bit sluggish, but it's not always obvious which component is the cause. For example, did you know that showing graphs in the TSPS actually connects to the TSIM to request all of the data before displaying it in the TSPS? This means the performance of the TSPS can be directly affected by the performance of the TSIM. You might see the TSPS or TSIM servers consume more than the expected amount of CPU or memory. Perhaps they might give out of memory errors or even crash and create HPROF files. But how do you determine which process is causing the problem? And one of the fundamental areas of TSOM is the collection of data for monitoring your infrastructure. But if the TSPS is not showing data at all, is the problem at the knowledge module level where the collection actually occurs, or the patrol agent that takes the data from the knowledge module and makes it available for consumption? How about the integration service that receives the data from the patrol agent and passes it to a TSIM? Or maybe it is one of the TSIM processes that analyzes the information to see if thresholds are breached and notifications are required. Or perhaps even in the TSIM database where the data is stored for future reference. There's so many areas that can potentially cause a problem, BMC customer support could have to request log files from several different components in order to try to determine what the root of the issue might be. With such a large volume of data needing to be gathered and shared, sometimes having to be requested multiple times with high levels of debug as the issue is focused in on, this understandably led to a lot of customer frustration over the amount of data supplied and the length of time that a case may be open for. Therefore, we set about analyzing case trends to see if we could simplify this. This analysis led directly to the creation of the TSOM Health Check tool when we determined a large number of customer problems, and therefore cases raised with BMC support, were being caused by incorrect tuning for the size of the environment being monitored. This was often because the TSPS and TSIM were tuned on installation but were not retuned as that environment grew over time. So the Health Check tool compares the current TSPS and TSIM configuration to BMC's documented best practice tuning recommendations. While the tool can be run against multiple TrueSight versions from 10.7 onwards, the tuning recommendations are based on version 11.302 settings, as they've been adjusted over time in line with ongoing performance and scalability testing. It will also check for duplicate parameters, invalid control M characters, and some typographical mistakes within the config files. The tool will verify select Oracle configuration parameters on the TSIM, as these can also impact the behavior and performance of the various TSIM processes. Of course, not all problems are just about tuning. For example, some of the performance problems mentioned can be due to increased logging at debug level, especially if left on long term. The Health Check tool will print in the report any debug logging that is turned on. Our recommendation is always to only run debug when it is required for investigating a specific problem, and then to turn it off afterwards. The Health Check tool will also scan the logs for certain known error messages that have existing articles, which themselves will be referenced in the output report generated after execution. The tool will query the TSIM database and show both the counts of instances created and instances marked for deletion, MFD, which is when an instance is no longer being collected and can be removed. This is important because if the upper limits of a TSIM's capacity are breached, then further tuning will not assist. Instead, the approach changes to either speeding up the deletion of MFD instances, lowering the instance counts by reducing what is being monitored, or setting up another TSIM in order to move monitoring and reduce the load. As network infrastructure and operating systems can affect TSOM components, the tool validates ports between TSPSs and TSIMs and executes scripts for netstat details, OS patch levels, and other important version information. All of this means that rather than just request configuration files for review and log files for investigation, for certain types of problems we can ask for the Health Check tool to be run, then the output can be used either by customers to help themselves or by BMC support to guide adjusting where needed. This has led not only to a significant decrease in the amount of data being requested, but also has drastically reduced the time taken for such abnormalities to be identified and corrected. So where do you get this Health Check tool from? The TSOM Health Check tool was launched on BMC Communities and is available from there, as well as on BMC's FTP site and in the knowledge base as an article. So successful has it been since its launch that as new service packs for TSOM are released, the version of the Health Check tool which is current at the time will be laid down by the installer. For example, TSOM 11.303 installer included version 2.0 of the Health Check tool. Please note that since 11.303 was released, version 2.1 of the Health Check tool has been launched, so it is recommended to check for the latest version of the tool at the Communities page, FTP location, or in the Knowledge article. With this in mind, let me quickly cover some of the changes in version 2.1. First up is a new check on the startup procedure for TSIMs in high availability setup. The PKIX error on the page can be seen in the TrueSight log files when a HA split brain scenario occurs. This is when both primary and secondary TSIMs are trying to be active at the same time, and this error can be seen in both 11.301 and 11.302. However, code changes in 11.303 means that the secondary TSIM may no longer actually start if there is a problem with certificates, or indeed if there are port restrictions between the TSIMs, or they just cannot communicate to each other as expected. The advice for high availability setups especially, therefore, is to download the latest version of the Health Check tool, run it, review the output for any highlighted concerns, and address those before running the 11.303 upgrade. Another issue that can affect TSIMs in a HA setup, there are occasions when the secondary TSIM cell's MCDB, where all the events get stored, gets out of sync with the primary TSIMs. The new Health Check tool will pick up on errors in the logs and highlight if this is occurring in the report. Version 2.1 also checks the dates of the Sybase full and incremental backups. It will display the number of hours since the last backup and therefore give an indication of when the backup might not be happening. And please be aware that version 2.1 now adds the server hostname to the file name of the report. If the report is to be shared with BMC customer support and the hostname needs masking, please make sure to edit the report name accordingly. Just before we look at the tool itself, a brief moment on items that are likely to be added to a future release. The TSBS can suffer with the same type problems as the TSIM HA startup, so a check for the TSBS should be added. TSIM fix and service pack levels could be verified and warnings given if the most recently available version is not yet applied. These fix and service packs contain fixes for a lot of defects, as well as new features, and therefore we would always advise to be on the latest version. Given how important the self-health notifications can be, it is surprising how often this is not correct, so the Health Check tool should be updated to indicate whether it is set and what it is set to. The Health Check tool is refreshed and released as and when required, therefore specific dates cannot be given. Okay, now let's run through the Health Check tool itself. In the demonstration, I'm going to download it from the FTP site, which includes both the zip for the tool itself and a README file containing the instructions to follow in order to install and run the tool. As per the instructions in the README file, the installation is just extracting the downloaded file to the appropriate TSIM or TSBS home directory using the default environment variables. It is important to use the same user to extract the file as was used to install the TrueSight component. This makes sure the right permissions will be given to the files on extraction so it can be run correctly. Execution of the tool is done from the utility TrueSight Health Check directory, which is created under the respective home directory. Whether being run against the TSIM or the TSBS, it is the same TrueSight Health Check command for both, and is either the .bat file when on Windows or the .sh file on Linux. The command prompt will show the steps which are being processed by the Health Check tool. Once the tool is finished running, it will advise on the number and severity of the issues found, and also to check the summary report for details of the action items that need attention. This is where our customers can really help themselves, as by running the tool periodically and implementing the suggestions given, they can make sure their installations are tuned appropriately and not suffering from known problems that can be addressed without the need for BMC customer support intervention. For this demo, I have asked a colleague to log into a TSIM and make changes to whatever they feel like that could impact its performance or hamper investigation of a problem. I do not know what changes they have done and will only be using the tool to guide me towards resolving the problems. Let me now kick off the FTP download and install, and then, while the Health Check tool is running, which can take a few minutes depending on the size of the environment and how busy it is at the time, we can look at the general layout of the output in the report. I'm going to our FTP site, and I'm going to download the zip file and the README file. If we take a look at the README file, it contains all the information needed to install and run the tool. You'll notice that we need to go for the TSIM to extract the file into the BPM server home environment variable. So let's check to make sure that's set. And here it is. So this is the directory structure into which we need to extract the health check tool. I'm going to paste that directory structure into the extraction, and that's the installation complete. If we now navigate to the home directory, there's a utility directory and the TSOM Health Check directory which we've just created. You'll notice that we currently have 3 directories, conf, lib and scripts, and after running the tool there will be a 4th one called reports. Conf, lib and scripts are just the setup of the tool itself, while the reports directory will contain all of the output that gets created. So now let's run the health check tool. And you can see it's setting up the environment, and it will now go and run through all the scripts that are needed to produce the output report. So let's go back to our deck and have a look at the report layout. Here we have an extract from a report, and I'll explain the headings and what they represent in order to familiarize yourself with them. The first column is validation type. This is broken up into categories such as configuration, which covers the details of the component it is run on or the tuning parameters. Log analysis, which highlights core HProf files as well as known errors that are occurring in the logs. Or operating system parameters, which hopefully need no explanation. The next field is topic name, which drills down into the validation type, identifying perhaps a particular configuration or log file, or indicating an OS-related detail. Field name gives a specific parameter name that is being checked for, while actual value represents the current value set for that field. Expected value, when populated, denotes the values that BMC believes should be in use, as per documented settings. Severity, though, is the first place you should be looking at the report for, with values of critical, error, warning, or info. It would be our recommendation to action any item which has a severity of critical, error, or warning. The user action field will give some details that customers can use in order to address the line item, while the comment section expands on this where more explanation is required. Finally, the knowledge article column will populate when externally published articles are available that match the issue found. These can be found in our knowledge base online. Let's go and look at the new report on our test TSOM. If I just scroll to the top where we started the execution of the health check tool, you will see it steps through initializing, executing prerequisite checks, and then all of the items that are going to be verified, such as OS configuration, performance tuning parameters, configured properties, scanning the logs, executing database queries, checking ports. Step 9 is only valid in a HA setup when it looks for the other node that's available. It executes other scripts to collect OS information, network data, and then consolidates that into report generated. It even gives us a nice little summary to show that we have 1 critical and 5 error severity issues found. It also indicates the name and location of the report that we need to go and review. So let's go and do that. As you can see, a reports directory has been created. And in here we have our HTML file of the output report. This tells me that this TSOM is a medium environment and it's running a Sybase backend database. It's also version 11.301. The report is ordered by the severity column with critical, error, warning, and then info as it scrolls down. If we look at our first critical error, it's with regards to available physical memory. I will have to discuss this with our VM team in order to address that one. Our next issue is an error, and it's repeated 3 times, so it looks like it affects multiple things. User actions explain that we have a new garbage collection method that can be used, and the comments field is telling me there are 3 different files affected by the same thing. There is also an article number referenced. BMC have ungated access to our knowledge base. What this means is that externally published articles, which are therefore also on our communities pages, can be searched via Google or another search engine of your choice. So let's try looking for this one. And we found our article. If we take a look at the details of this article, it tells us that we can change some garbage collection settings, and the effect of which will reduce the overall memory consumption of these processes. So we can now follow this article and address the garbage collection settings. We'll navigate to the PW Pronto conf directory, and we're looking for PN agent control, PNJ server, and pnrate.conf files. We'll make sure to take a copy of these. And then we'll open them up for editing. The article says that we're going to make the same changes in each of the files. So I can copy the details from the article and start making some changes. Here's the section we're looking for. As it's the same in each file, I'm just going to copy this, save the file, and repeat in my next file. At the end, we should restart the TSOM in order for the new configuration to take effect. But as we have other items to address, I'm not going to do that right now. If we go back to our report, the next thing that we're being told is with the HProf scanner, and it's indicating that we found some HProf files. There are suggestions that this TSIM might not have enough memory, and we saw above the critical messages telling us the same thing. Interestingly, both of these are old. They're from last year, and so they are unlikely to be useful to us now. If BMC support asked me for a zip of the logs directory or a pwdump output, these hprof files would have been included and made the file I had to send much bigger than it needed to be. So let's go and delete these from the logs directory as it says. I'm going to organize by size, and here are my hprof files. I'm just going to remove these. And that makes any subsequent files that I have to send to BMC a lot smaller. Moving on through our report, we're now into warnings rather than errors. And here we have some tuning that needs to be done, in particular for max heap, where our current value is set to 2048, and whereas it should be set to 4096. Similarly, with the pnagentcontrol.conf file, max heap is currently at 1024 and should be 4096. In the same file, the min heap parameter is the same value, 1024, but somebody has made a typo and put an L rather than an M. These files are held in the pw custom conf directory, so let's go and address those. We're looking for pnjserver and pnagentcontrol.conf. We need to adjust our max heap setting to 4096. Save the file. And in pnagentcontroller, we need to correct our typographical mistake and also adjust the max heap. Save the file. Back to our report once more. It's another indication that there is not enough memory on this VM server. I currently only have 16 gig allocated, and for the size of my environment I should have 32 gig. Again, this is something I need to address with BMC IT, who look after these VMs. What's next? We have a lot of debugging turned on at present. Leaving this on when it is not needed can really impact performance, so let's turn it off. There are a lot of JServer entries, so I imagine that the full process debug has been left on. I can check this with a pw debug list command. You will notice that some other areas of debug are on, and this is okay if they're not highlighted in the report, because these ones are on by default. And if we look at JServer, you can see that all of the items, for the most part, are turned on. So let's turn that off. pw debug off -p JServer and then we will check to make sure it's turned off by running pw debug list again. And you can see my JServer debug is now off, other than the ones that are on by default. My colleague really wanted to see if he could test the tool, as we are not quite done yet. There are problems highlighted with both the incremental and full backups. Now earlier we deleted some large HProf files, so perhaps the disk space was too low for the backup to take place. We can look at the pw pronto logs directory and the dbarchive.log. And it was quite happily doing backups until last Sunday when there was not enough space. It could well have been due to those HProf files. The backups are stored in the pw dbarchive directory structure. There should exist here a file called storm_hostname.db for the full backup. There should also exist an incremental directory which holds the incremental backups. We're told in the report that we should be able to run the command pw database archive in order to make sure that we have a full backup. As we've deleted some HProf files and we know that disk space was an issue, we can just try running this and see if we then get a full backup. Just have to confirm the default location. We now have sufficient space for the database backup, so let's run this. If we go back to our Explorer, we can now see that there is a storm_hostname.db file created. So this has resolved the problem with the full backup. We can also verify to make sure the incremental backup will work by running the same command with -inc for incremental on the end. Again, the output of the command tells us that under pwdb archive, the incremental directory should now exist, along with the backup log. And here it is. Back in our report, you will see that we've now addressed all of the error and warnings that we were given, and the remaining entries in the report are at info level. This means that parameters have been checked and the values correspond with what is expected for the size of the environment. You can see that we check a lot of different tuning. It's also showing us the operating system parameters that are all okay. And here are the instance counts and MFD, mark for deletion counts, that were mentioned in the webinar. Okay, now we can go back and run our health check tool once more and see what the report gives us. We haven't been able to address the amount of memory that's available to this VM, and therefore we should still expect to see one critical in the report, but hopefully everything else has been addressed. This is quite a small TSIM, so hopefully its execution will not take too long. If I navigate to our utility TrueSight Health Check directory and the reports directory, we can drill into each of these directory structures and see that there will be one folder created for each iteration of the health check tool being run. We now have our summary report and also the command ended indicating only one critical issue is found. Let's have a quick look at the report. Indeed, the only problems that we have on this TSIM server now are available physical memory and total physical memory, which I will get addressed with BMC IT. For your reference again, here are the links that we've used or mentioned within the webinar. The health check tool being available on communities, FTP download, and in a knowledge article. I hope you found the demo of the TSOM Health Check tool and reviewing its output valuable. In summary, this tool is great to help verify that the tuning of your TSPS and TSIM matches the size of your environment as it is today, and will also highlight known problems that could be affecting the peak performance of your TSPS and TSIM. You can run the tool as often as you think is appropriate and use the report to help you self-solve various issues by making sure you implement the suggestions made even without customer support being involved. Should you have addressed all of the critical error and warning issues flagged, yet still find yourself facing a problem with a TSPS or a TSIM, then run the health check tool once more for the latest state, zip up the whole of the reports directory and make it available when you raise a new case with us. Supplying this early in the case's life should entirely negate the need for you to provide the usual configuration files for review. It will ensure that you are not including gigabytes of unnecessary HProf files and decrease the number of times logs are requested for certain types of problems. This means there should be less back and forth between customers and BMC support and should result in speedier case resolution times. And that concludes my presentation, so I will hand you back over to Greg.
Thank you, Jonathon. And to wrap up our session to talk about our self-help and contacting BMC, the Connect with TrueSight webinar series schedule is located on this communities link. And today's presentation will be posted in communities as well as our YouTube channel available at this link. To contact technical support via web, phone, or email, as well as these social channels. Wanted to thank you for joining today, and that concludes our session.